All right, hello, Calc C. We're going to go through here and talk about some examples. So the first one I wanted to give you was, let's find the area bounded by y equals rad x, y equals x minus 2, and y equals 0. So we can pretty quickly see that when we draw this, rad x looks like this, x minus 2 looks like this, and y equals 0 is here. So I have this lovely shaded region here. And we've been talking about finding area between two curves. We're going to do top minus bottom. We actually have to break this up into two regions because here we can see that rad x is on top and 0 is on the bottom. Whereas in this other region to the right, what is on top is still rad x, but on the bottom is this line, x minus 2 is on the bottom. So because I'm touching two completely separate functions, I have to set up two different integrals. So for my blue region, my area is going to be the integral. Now where is this point right here where it stops hitting? It hits at 2, 0. So I'm going to accumulate from 0 to 2 of top minus bottom. So rad x minus 0. And for the green, I'm going to integrate from 2. So where does this intersect? At 4, 2 of top minus bottom. Don't forget those parentheses because you're going to have to distribute that negative. So to find this total area of the region, I'm going to have to add these two up. All right, so let's look at another example here. Let's look at the area bounded by y equals 1 and y equals cosine squared of x. And I just want to look in the first period. Actually, let's just look from 0 to pi. So y equals 1 looks like this. Cosine of 0 is 1, squared is 1, it dips down to 0, and back up to here. So I'm looking at this lovely region here. I can see that 1 is on top and cosine squared x is on the bottom. And if I want to get an exact answer, which is code for no calculator, then I'm going to have to do the integral from my x values go from 0 to pi. What function is on top? What function is on bottom? Dx. Now I can quickly see that my rules of integration so far are not going to work with this, but I happen to know that sine squared plus cosine squared is 1. So 1 minus cosine squared x simplifies to sine squared of x. Have I made my life easier? Absolutely, because I know by my double angle formula, this becomes the integral from 0 to pi of 1 minus cosine of 2x all over 2. And this is a pretty straightforward antiderivative. The antiderivative of 1/2 is 1/2 x. The antiderivative, again, the negative 1/2 is going to hang out. The antiderivative of cosine of something is negative sine of the something. And I'm going to have to divide by 2 again. And I'm going to evaluate that from 0 to pi. A little algebra here. I get 1/2 x plus sine of 2x over 4 evaluated from 0 to pi. So one last one that I want to give you an example. So we talked a little bit about when I have an enclosed area. So if I want to find the area bound by y equals x squared minus 2 and y equals 2, I didn't give you the points of intersection. So hopefully you see this and you think x squared minus 2 is a lovely parabola, y equals 2 is here. I can see that the line y equals 2 is always on top. The parabola is always on the bottom. So with a little teeny tiny bit of algebra, I can find these x bounds and integrate from x1 to x2 of top minus bottom. For the last example that I want to talk about here is if I have a graph of, let's look at the area bounded by y equals rad x, y equals 0, x equals, let's do a nice round number, 9. So we've been talking about integrating in terms of x and in terms of y, and I really want us to be adept at integrating in both ways. So my area here in terms of x, that means I'm going to use x bounds. Well, my x bounds go from 0 to 9. Rad x is on the top, the x-axis is on the bottom, dx. To find my area in terms of y, well, my y values accumulate from 0 up to rad 9. And in terms of y, we always want to do right minus left. So on this right side, I have the line x equals 9 minus I have rad x. But if I'm going to have y's on here, I need my variable to also be a y. So I can't put rad x in here. If y equals rad x, then x equals y squared. These are equivalent graphs, so what's going to go in here is this one. And this area and this area are going to give you exactly the same numerical answer. Go ahead and verify that you get the same thing both ways.